So in shift registers, we've talked about SISO and SIPO. Next is PISO and PIPO. So PISO, PIPO is parallel in serial out and parallel in parallel out. So we know that in SISO we need for SI we need n clock cycles, and SO we need n minus 1 clock cycles. So this is 2 n minus 1 clock cycles. And SIPO, SI we need n clock cycles, and PO you don't need any clock cycle. So this requires n clock cycles. So next we'll see the PISO and PIPO. So again we have 3 D flip-flops, D2, D1, and D0. And we know that you have a preset. So this is our preset. We have preset for each flip-flop, and if we give 0 to the preset, we get a 1 at the Q. And it's a synchronous circuit, so we have all the clocks synchronously connected. Okay, so we have a gate. This is a gate. Okay, so for this gate there is one mode control. Okay, this is a mode control, and you have another input which is the actual input. And this output of the gate is given to the preset. So if this mode is equal to 1, that means we are going to take the input in parallel. You are going to load the input in parallel. So whatever is the input, that should come to the Q. So we know that if preset equal to 0, Q will be 1. Preset equal to 1 means Q won't change. It is same as the previous. Okay. So initially we'll be clearing all the flip-flops using clear. You have the clear inputs. You'll be applying clear to all 0 to all the clear inputs. So initially Q2 is 0, Q1 is 0, and Q0 is also 0. Now you are going to apply the input. So initially this is 0. You are going to apply the input, say 0. So you want Q to be 0. This is initially 0, and you want it to be 0 itself. So when you apply 0 here, you already have a 0 here. You don't want that to change. So you don't want preset to be active because already 0 is stored inside the flip-flop. So if we keep preset equal to 1, then the Q will remain 0. If preset equal to 0, then Q will change to 1. You don't want that. Your input is 0 and you want the Q to be 0. So when input is equal to 0, this is kept at 1 itself. This just denotates that the input is taken in parallel. So I want to know what is the gate which you can use here whose output is 1 when its input is like this, 1 0. And mode is always 1 if you are considering only parallel inputs. Okay, so that is one. And another one is if you are keeping input equal to 1. Input equal to 1 means you want Q to be 1. Mode is 1 itself because you are taking the input in parallel. So when input is 1 and mode is 1, you want preset to be 0 so that this will change to 1. So which is that gate? If the input is 1 0, then the output is 1, and if the input is 1 1, then the output is 0. We are going to use and also if the mode is 0, that is you are not taking the input in parallel. So if I say that 1 0 is equal to 1 and 1 and 1 inputs are 1 and 1 it's 0, then you'll be thinking about XOR gate. So it's not XOR gate. That is if you are keeping say mode equal to 0, mode equal to 0, then also the preset should be 1 because mode 0 means you are not taking the parallel input. Whatever be the input 1 or 0, if mode is 0, preset should be 1. That is 0 0. That is in short mode and input. Mode 0 means preset, that is the output should be 1. I can be anything, 0 or 1. Mode is 1 means if this is 0, then preset should be 1. If this is 1, then the preset should be 0. So what is that gate? That is the NAND gate. Okay. So we are going to use NAND gate here. Yes, and these are your inputs. Suppose this is I2, this is I1, this is I0. Input, parallel input. I2, I1, I0 are the parallel input. And you are going to keep the mode. Mode means just parallel input. You are going to take the input in parallel. You are not going to take the input in series. So that is, I'm just naming it as mode, it can be anything. Okay, so suppose my input is say 1 0 1. So if I'm going to take the input in parallel, then mode will be 1 1 1, this will be 0. This is 0 means Q2 will be 1. This is 0, here you have a 1 1 0, this is a 1. So you already have a 0, that 0 will remain because preset is not active. This is 1 1 1, this is 0. So preset is 0 means this will become 1. So 1 0 1 is stored. 1 0 1 is what you are giving. 1 0 1 is what is being stored inside the register. So that is parallel input. So in the case of parallel input, are we giving any clock pulses to get this? No, because we know that preset and clear are both asynchronous. It does not depend on the clock. So if you give preset or clear at any point of time, irrespective of the clock, that will have an effect. So parallel input does not require any clock cycles. Now suppose you want the output to be in series. So you are going to take the output SO from the LSB. So if you are going to take it from the LSB flip-flop, first you are giving the inputs. So 1 0 1 is stored. Now how will you take this 1 0 1 out? All the bits out from this particular point serially. How many clock cycles do you need? So after storing, the first bit you already got without any clock pulse itself you got. Just by storing you got the first bit, first LSB bit. Now suppose I apply, so after the, before any clock is applied, I got the first bit in Q0. That is, this was 1 0 1. So this is my first bit, this is my serial out. So this I already got. Now if I apply a clock, what happens? Everything will shift to the left, sorry, right, from left to right. So this already gone, this 0 will come here, this 1 will come here, here there is nothing, so that will be a 0. So I got the first bit, I got the second bit. I apply another clock, so this 1 will come here, this 0 will come here. So here you don't have anything. So this is my third bit. 1, this is my LSB, middle bit, and the MSB. How many clock pulses you needed to get all the bits? You need 2 clock pulses. How many flip-flops did you use? 3 flip-flops. 2 clock pulses. So if it is n flip-flops, then you need n minus 1 clock pulses. For what? For serial out. So parallel in, serial out. Parallel in does not require any clock pulses. Serial out requires n-1 clock cycles. So you need in total n-1 clock cycles for PISO. Now suppose you are taking it output also in parallel. Okay, output also in parallel means what? You are not taking it from here. You are taking the output using LEDs from here. Okay, so after you give the parallel input data, you are taking the output from these three LEDs. So it's already there in Q2. You're just taking a wire and connecting it to an LED. So after the parallel input, it's already there in Q1. You're just taking an LED. Already there in Q0, you're just taking an LED. So how many clock pulses do you need? 0. Parallel input, how many clock pulses you needed? 0. So parallel is 0 clock pulses. Parallel out is also 0 clock pulses. So parallel out requires 0 clock cycles. And parallel serial out requires n-1 clock cycles. Serial in, serial out requires 2n-1 clock cycles, and serial in, parallel out requires n clock cycles. So each of these you can draw the timing diagram. Serial in, serial out, you can draw the timing diagram. Serial in, parallel out, you can draw. Parallel in, serial out, you can draw. Parallel in, parallel out, actually there is nothing much to draw. It's just you apply the input and you are getting the output. So rest of them you can draw the clock cycle, because in parallel out you don't require any clock cycles. So there is no timing diagram as such, because timing diagram we always draw with respect to a clock. So since parallel out you don't require a clock cycle, there is no timing diagram as such. Okay, it's just what you give as input, you are getting as output. Okay. So if we combine all these 4 modes of operation, so you have 3 flip-flops. This is your serial in, this is your serial out. You have a clock, synchronous clock. You have the preset. You have the mode, or you can also call it as load in parallel, that's the meaning. You're just combining everything and drawing. Okay. So this is my parallel inputs I2, I1 and I0. My parallel outputs Q2, Q1 and Q0. This is serial out, this is serial in, this is load equal to 1 for parallel input, 0 for serial input. So if you are going to operate it serially, serial input, then keep the load equal to 0 and then apply the input from here. If you are going to apply the input in parallel, keep this equal to 1. And before the starting of any operation, make the clear equal to 0, make Q2, Q1, Q0 equal to 0, then change the clear. So serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out. Right? So you can say that I2, I1, I0 are the parallel inputs. Q2, Q1, Q0 are my parallel outputs. You apply the serial input to D2 and take the serial output from Q0. Serial in, serial out requires 2n minus 1 clock cycles. Serial in, parallel out requires 2n clock cycles. Parallel in, serial out requires n minus 1 clock cycles. Parallel in, parallel out requires 0 clock cycles. So if you are asked to just explain about the shift register, you can draw the circuit and explain all the 4 modes of operation. If you are asked to explain each one of these or any 2 of those, you can draw separate diagrams as we did earlier and explain all this, and you can draw the timing diagram for all except the PIPO.